Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an Associate Professor in the Department of Electrical and Electronics Engineering. Today's we are going to discuss about on a numerical problems on the mesh and supermesh analysis. So we have already discussed about the how to apply the mesh analysis, and also we have discussed how to apply the supermesh analysis. So in today's class, we are going to discuss the various numerical problems, which means the various kinds of circuits that we will consider, and for each circuit, how to apply the mesh analysis, and as well as what is super mesh analysis and when we need to apply the super mesh analysis. So like these things we will discuss in today's class. So we will start with first a simple electrical circuit with 2 loops. Then after we will go for the 3 loops. Then after we will go for suppose if there is a dependent source, then how to apply the mesh analysis. By applying this mesh analysis, how to find the loop currents, and as well as the current flowing through a particular resistor, or the current flowing through each resistor, or the voltage across a particular resistor. So like this we can find, and again as well as suppose if there is a AC network, okay, then again how to apply this mesh analysis. Of course the procedure is same, okay. Then how to solve these mesh equations, okay, because in this class I have considered only up to maximum 3 loops. So then if there are 3 loops, then we will get the 3 mesh equations. Then how to apply the Cramer's rule to solve the the variables like I1, I2, I3 from those 3 equations. So like this we will discuss in this today's class. So here first let us start with a simple circuit. So here for this particular circuit, first let me read the problem here. In the circuit shown in the figure, determine all branch currents and the voltage across the 5 ohms resistor by the loop current analysis. So which means by loop analysis we have to find first of all we need to determine all the branch currents and as well as the voltage across the 5 ohms resistor that we need to find here. So for that, let us first identify how many number of loops are there. So here for the given circuit there are 2 number of loops, so that we will get 2 loop currents. So the loop currents, namely we can call it as a I1 and I2. So the current flowing through the loop 1 is I1, and the current flowing through the loop 2 is, let us consider here, I2. And also let me indicate for our simple understanding. So let me just indicate the nodes also here. This is node A, B, C, D, and E, F, so that we can consider each loop. So first let us consider a loop. Okay, so for loop here A, B, C, D, A. Let us consider this loop A, B, C, D, A. So for this loop, let us write the voltage or the loop equation. So which means here the loop equation is nothing but we just simply apply the KVL across across the first loop. So as we know, according to the Kirchhoff's voltage law, the algebraic sum of the voltages in a particular loop is equal to 0. So here anyway here the current the loop direction it is up to us, but usually here there is a voltage source is there, so that's why here the current will flow from high potential to low potential. So that's why we usually starts from high potential. So that's how here it is also. Let us consider here it is plus minus and plus minus, okay, and but here it is minus and plus, right? So then again here it is, let us consider plus and minus, but here it is minus and plus, right? So then when coming to the loop equation, let us start with here from the 3 ohms. So here the current flowing through this 3 ohms resistor is only I1. So which means here let us consider here it is V1, okay, and here it is V2, and here it is V3, and let us consider this is V. Then here V1 plus V2 plus V3, okay, minus, because here it is minus plus, so minus V equal to 0. So or in another words here V1 plus V2 plus V3, which is equal to V. Then here V is the voltage across the 3 ohms resistor, V1. So the current flowing through this 3 ohms resistor is, we have considered I1, and the resistor is 3. So which means here it is 3 into I1 plus here V2 is the voltage across the 5 ohms resistor. But here the current flowing through the 5 ohms resistor, or let us, here the 5 is the resistor, and when coming to the current flowing through this 5 ohms resistor is, with respect to loop 1 here the current is in this direction, and with respect to loop 2 here the current is in this direction. But here we are taking I1 as a reference current, so that's why, so here let us consider I1 is the positive current and I2 is the negative current. Then the current flowing through this particular branch, here it is I1 minus I2. So that's why here 5 into I1 minus I2 plus, then again V3 is, here it is the voltage across the 6 ohms resistor. So which means 6 into the current, here it is I1, which is equal to, here what is the V value, 50. Right. So if you simplify this equation, then 5 plus 3, here it is 8, and 8 plus 6, here it is 12 I1. So 12 I1 minus 5 I2, which is equal to 50. Let us consider this is equation number 1. Then coming to the second loop. Okay. So here let me just erase these things, and then when coming to the second loop here. Yeah. So then for loop 2, now we are writing the equations for loop 2. So for loop, the loop 2 is, let us consider with from B, E, F, C, B. Okay. So for this loop again, here the current direction, here it is, they have considered like this. So which means again here it is plus minus. Okay, let us consider plus minus, and this is also plus minus, and this is also plus minus, and here also plus minus is there, right? Then if you start from, let us consider here, let us start from 2 ohms resistor. So here 2 into, here the current flowing through the 2 ohms resistor is I2, 2I2 plus, okay, and then of course 25 is there, then after that 25 plus, here the voltage across the 8 ohms resistor, here 8, and the current is I2 plus 5 into, here I2 minus I1, because we are taking the reference current direction is as the I2 direction, so that's why I2 minus I1, which is equal to 0. Then if you simplify this, so here minus 5 I1, and what are the I2 terms? Here 2 plus 8, 10, and 15. So 15 I2, which is equal to 25. So let us consider this is equation number 2. Then here by solving equation number 1 and 2, then you will get the value of I1 and I2. So by solving these two equations, then the value of the I1, here it is, you will get it as a 3.37 amperes, and I2 you will get it as a minus 0.541. So this is how we can apply the loop analysis or the mesh analysis. So here the important thing in the mesh analysis or loop analysis is, okay, the direction of the current that we are considered, and also the polarities of the voltage. Okay, so because based on that, because as you can see here, in this case the 25, here we have placed plus 25 because the current direction is plus to minus, but here in the previous case in the loop 1, here it is minus to plus, it is flowing, so that's why reverse, so that's why here I have kept minus V. So like that, here the polarities are very, very important, because if you get confused in the polarities, which means the plus and minus, then you will get the wrong answers for the I1 and I2. Okay, so that's why it is very important, right? Then coming to the second problem. So in the second problem, here I have considered the 3 loops, right? So again here in the figure, determine the mesh currents I1, I2, I3. So I1 is the current flowing through the first loop, and I2 is the second loop, and I3 is the third loop, right? So here also first we need to write the loop equations. Okay, so first let us write the loop equation or apply the KVL for the loop A, B, C, D, E, A. So which means here A, B, C, D, E, A. So this is the loop. For this particular loop, we need to write the what is that voltage equation or the KVL. Okay. So here, as you can see, let us start with from the 1 ohm resistor. So here in the 1 ohm resistor, what is the current here? The I1 direction is in this way. This is the I1 direction. Okay. But in this 1 ohm resistor, I2 current I2 is also flowing, but I2 direction is in the opposite direction. So that's why 1 into V is equal to I into R. So V is equal to I is I1 minus I2 and 1. So that's why here 1 into I1 minus I2. Right? So 1 into I1 minus I2 plus, and then again here the 2 ohms resistor is there. In the 2 ohms, okay. So again here, what are the currents that are flowing through these 2 ohms? Here I1 is in this direction, okay, and here I3 is in the opposite direction. So that's why here the current flowing through this 2 ohms resistor, here it is I1 minus I3, right? And again here also plus 2 minus, so that's why plus 6, okay. But here it is minus 2 plus, so that's why minus 7, which is equal to 0. Right? So let me explain again. So here this is 1 into the current, because V into V is equal to I into R. So I here it is the current flowing through this 1 ohm resistor is, because this 1 ohm is in between the loop 1 and loop 2. So which means with respect to the loop 1, the current is flowing, I1 is flowing in this direction, and with respect to loop 2, the current is flowing in opposite direction. So that's why here the current flowing through this the branch CD or the resistor 1 ohm, here it is I1 minus I2. So that's why here 1 into I1 minus I2, okay. Then plus here it is 2 into I1 minus I3, because in the resistor 2 ohms, the current flowing through these 2 ohms is I1 minus I3, because with respect to the loop 1, the current is I1, and with respect to the loop 3, the current is I3. So that's why here plus 2 into I1 minus I3, and again there are 2 voltage sources as there. This voltage source polarities are plus minus, so that's why here it is plus 6, and but here it is minus and plus, that's why here it is minus 7 is equal to 0. Then if you simplify this, so here 2 plus 1, here it is 3 I1, okay, and minus I2, and minus 2 into I3, minus 2 I3, which is equal to 6 minus 7 is equal to minus 1, and if you send to the right hand side, then you will get 3 I1 minus I2 minus 2 I3 is equal to 1. Then similarly, we can apply the KVL to the second loop. So the second loop, here it is C, F, G, D and C, right? So for this particular loop, now again we are applying the KVL. So of course, what are the various resistors are there? 2 ohms, 3 ohms and 1 ohm. So let us start with the 2 ohms resistor. So what is the current flowing through this 2 ohms resistor? Here it is the current I2. So that's why then the voltage across the 2 ohms resistor is 2 into I2. So that's why here it is 2 into I2, right? Then coming to this 3 ohms resistor. Then what is the current flowing through this 3 ohms resistor? Then the current flowing through the 3 ohms resistor, here you can see with respect to I2 is in this direction and I3 is in this direction, right? So which means here then the resultant current flowing through the 3 ohms resistor is I2 minus I3. So that's why here then the voltage across the 3 ohms resistor, here it is equal to 3 into I2 minus I3 plus again here 1 ohm, okay. So in the before case, here the current flowing through the 1 ohm resistor that we have considered as I1 minus I2, but here we are considering as I2 minus I1. Why? Because here the actual current direction flowing through this the 1 ohm resistor, now we are taking as the reference current is I2. So that's why we should consider the I2 as the positive, and if the I1 is in the same direction, then we usually write I2 plus I1, but I1 is in the opposite direction here. So that's why here we should write here, because here I3 is in this direction and I1 is in this direction, sorry, I2. So that's why here 1 into I2 minus I1, which is equal to 0. Then if you simplify this, here minus 1 I1 is there, and 3 I2 plus 2 I2 and 1 I2. So 3 plus 2, 5 plus 1, 6. So plus 6 I2, and here 3 into minus I3. So 3 I3, which is equal to 0. So let us consider this is equation number 2, right? Then again there is another loop, okay. So this is the loop. The loop here it is D, G, H, E, D. Then now we need to apply again the KVL to this particular loop, okay. Then applying the KVL to this particular loop, let us start with this 3 ohms resistor. So here then the current flowing through this 3 ohms resistor, again here it is, as you can see, I3 is flowing in this direction and I2 is flowing the opposite to the I3 direction. So that's why here then 3 into I3 minus I2 plus again here 2 is there. So in the 2 ohms resistor also the currents are in opposite direction, because here I2 is in this direction, I3 is in this direction and I1 is in this direction. So which means here the current flowing through this 2 ohms resistor with respect to the loop 3 is I3 minus I1. Or suppose if you want to find the current flowing through the 2 ohms resistor with respect to the loop 1, which is I1 minus I3. So that's why it is very important based on based on the reference current direction. It will depends whether it is I1 minus I3 or I3 minus I1. So here the reference current direction that we are considering is I3. So that's why here it is I3 minus I1. Plus again, here in the 1 ohm resistor, the current is flowing through 1 ohm resistor is I3. So 1 into I3. So here again minus 2 plus. So that's why here it is minus 6, which is equal to 0. Then if you simplify here, of course, 2 into minus I1. So minus 2 I1. Here minus 3 I2 and plus. So 3 plus 2, 5 and plus 1, 6. So 6 I3, which is equal to 6. Then now we got the 3 equations from the 3 loops. So the first equation is 3 I1 minus I2 minus 2 I3 is equal to 1. And the second equation minus I1 plus 6 I2 plus 3 I3 is equal to 0. And the third equation is minus 2 I1 minus 3 I2 plus 6 I3 is equal to 6. Now we need to solve these 3 equations to get the value of I1, I2 and I3. Right. So there are various ways to solve these 3 equations. Okay. So here one simple method I am going to explain here. That is the in matrix the Cramer's rule. So by using this Cramer's rule, we can find the value of I1, I2 and I3. So further here, first let us write these equations in the form of matrix. So further here, the first matrix having the coefficients of I1, I2, I3. So first row here it is 3, minus 1 and minus 2. So here it is minus 1, 6, minus 3 and here it is minus 2, minus 3 and 6. So this is the first matrix. Right. So into I1, I2, I3 which is equal to here V1, V2, V3 because what are these 1, 0, 6? These are the voltages. Okay. So right, that's why here you can see here 3, minus 1, minus 2 and this is the coefficients of the I. Okay. And this is the current matrix and this is the voltage matrix. Okay. So in other words, this is the impedance matrix. Let us consider Z. So Z I is equal to V. So then from here, what we need to find here, we need to find I. Okay, so I is equal to, if you send Z this side, then you will get Z inverse into V. Z inverse into V. So then if you just find the Z inverse and multiply with V, then you will get the I value. That is one method. And another method here it is, you just apply the Cramer's rule. So by applying the Cramer's rule also we can find the values of I1, I2 and I3. So here this is the I matrix and this is the V matrix and this is the Z matrix, right? So first if you want to find I1, then I1 is equal to, because you have to replace the first column with the value of V1, V2, V3. Okay, then substitute the value of V1, V2, V3 and find the determinant, okay, by delta. So here delta is the determinant of the Z matrix. So here this is the determinant of the Z matrix. Then if you want to find the determinant of the Z matrix, as you know already, so here 3 into, okay, if you this then 3 into 6 into 6 minus, okay, and minus 3 into 3. So like that you can find, I mean plus again like that you can find here. So here, so 3 into 6 into 6 minus 3 into minus 3 plus 1 into, okay, because actually minus, but minus of minus plus here. So 1 into minus 1 into 6 minus 2 into minus 3. So I think I no need to explain how to determine the determinant of a matrix. Okay, so that we have already learned. So that's why here I am not going to explain again. So this way we can find the determinant of that Z matrix, and the determinant of the Z matrix here we got is 39. Right. Then I1 is equal to, here we have replaced the first column with V1, V2, V3. So here the V1, V2, V3 of the first column are 1, 0, 6. So that's why here we have substituted here 1, 0, 6 and the remaining elements are same. Then find the determination of this particular matrix. Then the determination of this particular matrix is here. So then finally you will get the I1 value as 3 amperes. Then similarly you can find I2 and I3 values also. So here I2 is again here in the key, if you want to find I2, then the second column must be replaced with the V1, V2, V3. So here V1, V2, V3 are what is that 1, 0, 6 and the remaining elements are as it is. Then find the determination of this particular matrix, and already we have calculated the determination, that is delta of the impedance matrix or the Z matrix. So that is 39. Then substitute the values here. Then you will get finally the I2 as a 2 amperes. And similarly, when coming to the I3, so here I3 also, in case of I3 now, we should replace the third column from the Z matrix with a V1, V2, V3. So that's why here the third column of the Z matrix that we have replaced with 1, 0, 6, which is the voltage matrix V1, V2, V3. Then again, determine the what is the determination of this particular matrix by delta. So delta we have already calculated, which is 39. Then substitute here the 39 and calculate the determination of this particular matrix. Then you will get the value of the I3, which is equal to 3 amperes. So now we got the value of I1, I2, I3, right? So according to the, in the given problem, what they ask us, of course, they ask us to find I1, I2, I3. Now we have calculated the values of I1, I2, I3. So here the value of I1 is equal to 3 amperes and the value of I2 is equal to 2 amperes and the value of I3 is equal to 3 amperes. So which means whenever you are having, of course, if you are having only two equations, then we don't need to go for this Cramer's rule. By simply we can solve those two equations so that we can find I1 and I2 values. But if you are having more than two loops, let us consider three loops, then in this, if you are having the three equations and three variables, then it is easy to find the values of the variables I1, I2, I3 by using this Cramer's rule. Then now we are going to solve another problem. So as you can see here in the given problem, it is having 1, 2, 3, 4 loops are there. Okay, but here of course 4 loops is nothing but we will get the 4 equations. So it is a little difficult to solve these 4 equations or to find the 4 variables. So that's why here I'm just looking is there any possibility to reduce or eliminate one loop so that we can get the 3 loops. Yes, of course, here as you can see here, these current source and these resistor, these two are in the parallel. So which means now these current source can be converted into the voltage source. Then how we can convert the current source into the voltage source, that we have already discussed in the topic voltage, the source transformation. So which means the current source can be transformed into voltage source and the voltage source can be transformed into current source. But there is one condition. So if there is a internal resistance, okay, of the current source is in parallel with that particular current source, then only we can convert that current source into voltage source. And if there is a series resistance with the voltage source, then only we can convert that particular voltage source into current source. So that's why, of course, here this is a current source and current source having the internal resistance is in parallel with this current source, so that we can convert this current source into the voltage source. Then voltage source V is equal to I into R, right? So here I is 8 and R is 10. So which means here V is equal to 80 volts. So here as you can see here, this is 80 volts that I have replaced, and again the resistance is in series with this voltage source, right? So now the total network is reduced into the 3 loops. Okay, so 1, 2, 3. So now again like in the previous case, okay, in the previous problem, so we can apply the same way the KVL for these 3 loops. Then we can find the current values of I1, I2 and I3. But actually, according to this given problem, they ask us to find only the value of Ix, which means the current flowing through the 2 ohms resistor. So here the current flowing through the 2 ohms resistor is nothing but the loop current I2. So we need to find the loop current I2 so that we can find the current flowing through the 2 ohms resistor, which is Ix, right? Right, here also same way, first apply the KVL to the first loop. The loop here it is A, B, C, D. Okay, so then here again the same way, here it is plus, minus and plus, minus. Okay, here the current is in this direction and here the current is opposite direction. So that here if you start from 8, so then the voltage across the 8 ohms resistor is equal to 8 into 1 ampere. 8 into I1, because the current flowing through this 8 ohms is I1, plus again 4 into here I1 minus I2, the same way as like in the previous case, 4 into I1 minus I2, and minus 100 is equal to 0. If you simplify, then you will get here 12 I1 minus 4 I2 is equal to 100. Then the same way apply the KVL to the loop 2 also. In the loop 2 again, let us start with this 2 ohms. Then the current flowing through this 2 ohms is here we have considered as a I2. So 2 into I2 plus here again 3 into, because the current flowing through this 3 ohms resistor is I2 and I3. But here we have considered the reference current direction is I2. So that's why here the current flowing through the 3 ohms resistor is I2 minus I3. So V into I into R. So I is here I2 minus I3 and R is 3. So that's why here 3 into I2 minus I3 plus again here 4 is there. In the previous case, the current flowing through the 4 ohms resistor is it was I1 minus I2, because in that case the reference current direction is I1, but in this case the reference current direction that we are considering as a I2. So that's why then the current flowing through this 4 ohms resistor, now here it is I2 minus I1. So that's why here then plus 4 into I2 minus I1, which is equal to 0. Then if you simplify this, then you will get the finally equation as a minus 4 I1 plus 9 I2 minus 3 I3 is equal to 0. So let us consider this is equation number 2. Right, then coming to the loop 3, so which is EGHF. Okay, so then apply the KVL to the loop 3 also. So let us start with this 10 ohms. So here the 10 ohms, the current flowing through this 10 ohms is I3. So that's why here 10 into I3 plus here the current flowing through this 5 ohms resistor is again I3. So that's why plus 5 into I3. And again here the current flowing through this 3 ohms resistor is here it is I3 minus I2, because here the current direction that we are taking, the reference current direction that we are taking is with respect to the loop 3, which is current I3. So that's why here the current flowing through this 3 ohms resistor is I3 minus I2. So then plus 3 into I3 minus I2. Okay, of course, anyway here the 80 volts voltage source is there and the polarity is with plus and minus. So that's why here we can add plus 80 is equal to 0. Then by simplifying this equation, then you will get here, of course, there is no I1 here. So that's why let us consider the coefficient of I1 is 0. So that's why 0 into I1 minus 3I2 plus 18 into I3 is equal to minus 80. So why? Because why we have just considered 0 into I1? Because now the same way like in the previous problem, we are going to solve these 3 equations by using the Cramer's rule, right? So here as you can see, the first equation is 12I1 minus 4I2 is equal to 100. There is no I3 term is there. So that's why here we have placed just plus 0 into I3. And similarly, the second equation minus 4I1 plus 9I2 minus 3I3 is equal to 0. And finally, the third equation, of course, in the third equation, we don't have the I1 term, but here for our understanding purpose, so just I have mentioned like 0I1 minus 3I2 plus 18I3 is equal to minus 80. Then again, first write this equation into the matrix form. So first let us consider here delta RZ, okay, because as we seen in the previous problem. So the same way here also we can write, so Z into I1, which is equal to V, right? Not I1 even, Z into I, let us consider Z into I is equal to V. So that here I is equal to Z inverse V, right? So here this is nothing but the determination of the Z. Here delta represents the determination of the Z. So here the Z matrix that is having the coefficients of I1, I2, I3. The first equation coefficients of I1, I2, I3 are the first row, and the second row are the coefficients of I1, I2, I3 of the second equation, and the third row is the coefficients of the third equation, the coefficients of I1, I2, I3 of the third equation, which represents the third row. Then find the determination of this particular matrix, okay, which is delta, or you can also call it as a determination of Z. Then finally you will get the value of the delta is equal to 1548. Then first, if you want to find the value of I1, then I1 is equal to the matrix, okay, actually the Z matrix. In the Z matrix, we should replace this first column with the voltage, what is that matrix, which is 100, 0 and minus 80. So that's why as you can see here, the first column is replaced with the voltage matrix that is 100, 0 and minus 80. Then find the determination of this particular matrix by the delta value. The delta is the determination of the Z matrix. Then you will get the value of I1, so which is equal to 9.26 amperes. And similarly, we can also find I2. In the case of I2, the second column is replaced with the voltage matrix. Okay. Then if you simplify, then you will get the I2 value as a 2.79. And in the third case, we should replace the third column as a voltage matrix, which is which is 100, 0 and minus 80. Then you will get the value of I3 here. The value of I3 is equal to minus 3.97 amperes. So now we got the value of I1, I2, I3. So I1 is the loop current, the current flowing through the first loop, and I2 is the current flowing through the second loop, and I3 is the current flowing through the third loop, right? So here, according to the given problem, what they ask us to find? They ask us to find what is the current Ix. Ix is the current flowing through the 2 ohms, what is that resistor. Then here Ix is equal to I2. So which means here the Ix value, here it is 2.79 amperes. So like this, here you can find the current flowing through any one of the resistors. So let us find, suppose if you want to find the current flowing through the 4 ohms resistor. Okay, what is the current flowing through the 4 ohms resistor? So in this case, you may get doubt like the current flowing through the 4 ohms resistor are I4. Okay, so which is whether it is I1 minus I2, okay, or I2 minus I1. Right? Suppose if you consider I1 minus I2, here I1 is 9.26, okay, and I2 is 2.79, and in this case here I2 is 2.79 and minus I1 is 9.26. Right? So when you consider I1 minus I2, you are getting here the positive value, okay, so the positive value, but here you are getting the negative value. So which means here in what case here it is I1 minus I2, because the current direction here it is as a I1 direction, so which means here it is in this direction, the current direction, but here it is the current direction is in this direction. So here when you consider the current direction same as the I1 direction, you are getting the positive value, and if you consider the current direction is same as the I2 direction, you are getting the negative value, which means here the current must be in a reverse way. So which means of course in the 4 ohms resistor the current must be flow in any one of the way, okay, either the same as I1 or I2, okay, but it should not flow in both ways, okay. So that's why then the actual current direction flowing through this 4 ohms resistor is the I1 direction, which is in this direction, okay. So that, which means here this one is correct. Of course, if you indicate just with a negative sign, this is also fine, right? Because in both the cases you will get the same value, but the only difference is here you will get the positive value and here you will get the negative value, because the positive and negative value represents the direction only, right? So this is how you can find the current flowing through this 4 ohms. Again, if you want to find, you can find in the 3 ohms and again 5 ohms. Okay. So like that, we can find the current flowing through any of the resistor and as well as the voltage across any of the resistor by using this loop analysis. Now, there is another case here, right? So here, of course, as you can see, one voltage source is there and another one current source is there. Okay. So in this case, how to apply the mesh analysis? But usually, I mean, just for our basic understanding, so here you are having 1, 2, 3 and 4 loops are there. Okay, 4 loops are there. But here, now we are going to reduce these loops, number of loops, because now let us see, is there any possibility to convert voltage source into current source or current source into voltage source, so that by converting the source transformation, then we can simplify the circuit, and after simplifying the circuit, now we will apply the mesh or loop analysis. Then we will write the mesh or loop equations. Then by solving those equations, we can find the values of I1, I2, I3, like the currents, right? So here, as you can see, this voltage source and this resistor, so this combination can be replaced as or can be transferred as a current source, right? So how we can transfer as a current source, because here as you can see, then I is equal to here, which is V by R. So here V is equal to 100 and R is equal to 10, then you will get 10 amperes, right? So that's why these voltage source can be transferred into current source, and the resistor again we have to replace within parallel with this particular current source. So that's how here we are replacing with 10 amperes and 10 ohms. And again, as you can see here, these 10 amperes and this 10 amperes current sources are connected across the same terminals, so that we can replace this. Okay, we can replace this 10 amperes and 10 amperes, because you can just add these two the currents, okay, so that you will get the 20 amperes, okay, and again here the parallel with the again 10 ohms resistor is there, but still here you are having 1, 2, 3, 4. Okay, now let us see, is there any possibility to reduce again this network? Of course, here again this combination can be converted, this current source can be converted into the voltage source. So then how we can convert this current source into voltage source? Again here V is equal to I into R, the same way, the same reverse way like in the previous case. So here I is equal to 20 and R is equal to 10, so then it is 200 volts. Okay, so that is how here the 200 volts and 10 ohms. Now we got only the 3 loops, 1, 2, 3. So now we can apply the same procedure as like in the previous case. Then you can find the current flowing through each loop. So let us write here the equations. So with respect to the first loop here, 10 into I1 plus again 10 into I1 minus I2, plus again 10 into I1 minus I3, which is equal to 200. So if you simplify this, how many 1, 2, 3, so 30 I1 minus 10 I2 minus 10 I3, which is equal to 200. So if you further simplify 3 I1 minus I2 minus I3, which is equal to 20, let us consider this is equation number 1. And then coming to the second loop, okay, so this is loop 1. And coming to the second loop, so with respect to I2, again here it is 10 I2 minus 10 into I2 minus I3, okay, and plus 10 into I2 minus I1, which is equal to 0. Then if you simplify this here, you will get 10 I1 is minus 10 I1, okay, and I2 1 here plus 10, sorry, here it is plus, yeah, so 310, so plus 30 I2 minus 10 I3, which is equal to 0. Then if you simplify, then you will get here it is, what is that, I1 minus 3 I2 plus I3, which is equal to 0. Let us consider this is equation number 2. Then for loop 3, here it is again 10 into I3 minus I2, okay, plus again 10 into I3 minus I1 plus 24 I3, which is equal to 0. Then here I3 is 24, 34 and 44. So 44 I3 minus 10 I1 and minus 10 I2, which is equal to 0. Then finally here you will get I1. So finally you will get here it is I1 or 10 I1 plus 10 I2 minus 44 I3, which is equal to 0. This is equation number 3. So then again by solving these three equations, by solving equation 1, 2 and 3, then we can find the values of I1, I2 and I3. So again you can apply the Cramer's rule or simply by using the calculator you can find the values of I1 and I2 and I3. Fine. Then now there is another problem. Okay, so in this problem we are having one dependent source. Okay, here the dependent current source is there and this current source depends on the voltage across this 3 ohms resistor. Okay, so the value of this current source depends on the voltage across the 3 ohms resistor. So then how to apply the loop analysis for this case? Of course, here is also very easy when compared to in the previous case. Okay, because as you can see here, first of all here Vx, what is Vx? Vx is equal to the voltage across the 3 ohms resistor. So what is the current flowing through the 3 ohms resistor? Okay, let us consider here the direction is I3. So I3 minus I2 is the current flowing through this 3 ohms resistor. So here what is the resistor? 3. So that's why here Vx is equal to 3 into I3 minus I2. Right? Then as you know here already I1 is equal to 10 amperes because the current source is there. So I1 is equal to 10 amperes that they are already given. Right? Then what is here the current source Vx by 8? Here Vx by 8 is nothing but, okay, because the current direction is in this way, which is same as I3. So I3 minus I1 here. So that's why I3 minus I1 is equal to Vx by 8. So which is equal to 0.125 Vx. Then already we know what is the value of I1. I1 is equal to 10 amperes here. Then substitute this 10 amperes in this place. Then you will get I3 minus 10 is equal to, okay, so 0.128 into 3 into, what is the Vx value here? 3 into I3 minus I2, then substitute here, then you will get I3 minus 10 because in this value, this equation you will get in terms of I2 and I3. So that you will get the two equations. Okay, so here 0.375 I2 plus 0.625 I3 is equal to 10. Then let us apply the KVL to the loop 2. Okay, because here the loop 2, by applying the KVL to the loop 2, you will get the equation in terms of I1, I2, I3. But anyway, we know the value of I1, so that's why here also you will get the equation in terms of I2 and I3. So that's why here it is 4 into I2 plus here 3 into the current flowing through here it is Vx. Then Vx already we know Vx is equal to 3 into I2 minus I3. I3 minus I2 there, but here with respect to the current I2, so that's why here we can write 3 into I2 minus I3 plus 5 into I2 minus I1, which is equal to 0. Then here minus 5 I1 plus, because if you simplify this, then you will get finally 12 I2 minus 3 I3 is equal to 50. Right? So then the simultaneous equations, because this is one equation and this is the second equation. So here we have just write these two equations, and by solving these two equations, we will get the value of I1 and I2. Of course, you can apply any one of the method, but here again we have applied the Cramer's rule. Okay, so by applying this Cramer's rule, you will get the value of I2 and I3, because I1 already we know, which is 10 amperes. Then the value of I2 here it is 7.1 and I3 is 11.74. So if you are having a dependent source in the given circuit also, the procedure is same and it is very simple. Then coming to the supermesh analysis. So as we know, when we need to apply the supermesh analysis, if there is a current source in between the two loops, okay, if there is a current source present in between the two loops, then we need to go for the supermesh analysis. Now let us consider again the same simple example to understand how to apply the supermesh analysis. Of course, without supermesh here, we are having the two loops. Let us consider the current flowing through the loop 1 is I1 and the current flowing through the loop 2 is I2, right? This is the common way. But here there is another supermesh that we need to consider. Here it is, as you can see, here I1, I2 are the two mesh currents, okay, with 2 amperes current source is common, okay. So then the supermesh we are drawing, combining these I1 and I2, because in between which two loops the current source is present, okay. So by considering the two loops, we are making it as a supermesh. As you can see here, this red line. So by combining these two, okay, we are making it as a supermesh, right? Then we are going to write the supermesh equation. So supermesh here it is nothing but, which means this total loop. So that's why, which means here the voltage across these 4 ohms and plus 6 ohms and plus these 6 ohms, 6 volts and plus these 2 ohms and plus this 10 volts. So first let us write the voltage across these 4 ohms. Here it is 4 into the current, here it is flowing through, here it is I1. So that's why here 4 into I1 plus here 6 into the current flowing through the 6 ohms resistor is I2 that we are considered. So that's why 6 into I2. Here plus 2 minus, so that's why plus 6. And plus again here the current flowing through this 2 ohms resistor is again I2. So that's why 2 into I2, but here it is minus 2 plus. So that's why here minus 10 is equal to 0. Then by simplifying this, you will get 4 I1 plus 8 I2 is equal to 4. Then again here, this 2 amperes is in between the loop 1 and loop 2. So which means the current flowing through this 2 amperes is I1 minus I2, not I1 minus I2 minus I1, because the direction here it is same as the I2. So that's why here then I2 minus I1 is equal to 2 amperes. This is another equation, right? Then by solving these two equations, then you can find I1 and I2 value. See here it is very simple. So I1 and I2 value. Then here the I1 is minus 1 ampere and I2 is equal to 1 ampere. Okay. So of course again if you substitute in this equation, you will get I2 minus I1. So I2 is 1 minus of minus 1 plus, then you will get 2 amperes. The same way, the same 2 amperes that you will get, right? Then coming to the same super mesh analysis. Okay, in case of suppose if you are having 3 loops, because in the previous case we are having only 2 loops. So in this case also same way, because here also we will consider this the super mesh has this, because in between these 2 loops we are having the super mesh. So that's why current source, that's why here we will consider this as a super mesh. Okay, then again this loop is as it is same. Then now we are going to write the loop equation. So first we are going to write the loop equation for this I1 current for this particular loop. So this is normal mesh, this is not the super mesh. So that's why we will write the same equation like as usually. So here 2 into I1 minus I2 plus 2 into I1 plus I3 minus 10 is equal to 0. After simplifying, then you will get 4 I1 minus 2 I2 plus 2 I3 is equal to 10. Then now we are going to apply the super mesh for this particular. See here also, you will get the same equation, because here 3 loops are there, then you will get the 3 loop equations. Okay. In the previous case, you are having only 2 loops, that's why you got the 2 equations. So, but here these three equations are, one is 3 loops, one is the normal loop equation, and second one is the super loop, the super mesh equation, and third one is the current source value in between the 2 loops. So that's how we will get the 3 equations. Then when coming to the super mesh, here it is let us start with here 4. Okay, 4 into I1 plus 2 into here I2, 4 into I2 plus 2 into I2 minus I1, and again plus 2 into I2 minus I3 minus I1, and plus 8 into I3. Okay, I3 is equal to 0. Then if you simplify this, then you will get finally here minus 4I1 plus 6I2 minus 10I3 is equal to 0. Then again here the third equation is with this current source. The current source is in between I2 and I3. So here the current direction is same as like the I3. So that's why here I3 minus I2 is equal to 2 ampere. So that's how, sorry, here the loop direction they have considered is in a reverse way. Okay. So that's why here the loop current direction I3 is in this direction, but we have considered the super mesh is in this direction. So that's why here we have placed minus 8 I3. So don't get confused here. So that's why here then the current source here is I2 plus I3 is equal to 2, because here the super mesh direction is opposite to that one. So that's why I2 plus I3 is equal to 0, because here I2 and I3 both are in the same direction as the current source direction. So that's why here I2 plus I3 is equal to 2. Then you got the three equations. This is one equation, this is two equation, this is third equation. And by solving these three equations, then you will get the I1, I2, I3 value. So here I1 is equal to 3.667 and I2 is equal to 2.16 and I3 is equal to 0.167. Like that we can find. So finally what they ask us to find the current through the 8 ohms resistor. So which means here the current through the 8 ohms resistor, here it is I3, then I3 is equal to 0.167 amperes. Then finally the final example. Okay, I mean one more example here it is. So here, of course, in between these two loops, there is a current source, but there is a resistor in series with this current source. Okay. Then in this case also, we will apply the super mesh. Okay. Because, of course, with the current source, okay, if, in series with the resistor is also not a problem. But if here it is a current source in between these two loops, then you must go with for the super mesh analysis. Then the super mesh, what is that, is like this, because here it is in between I1 and I1 and 3 loops. So that's why then you must make a super mesh by using the loop 1 and loop 3. And again, the same way you can write the, what is that, the loop equations. Okay. So then after that you will get the three loop equations. Then by solving these three loop equations, then you will get I1, I2 and I3 values. Right? Yeah. Then the third, the last problem here it is an AC circuit. Okay. Then apply the mesh analysis for this particular AC circuit. So the procedure is as it is same. As you can see here, there are three loops are there, and the three loops, let us consider having the three loop currents I1, I2 and I3. Right. So first let us consider the mesh I1. So I1. Then write the loop equation for this I1. So here let us start with 8 into I1 plus Z10 into, here the current flowing through this particular inductor is I1 minus I3. So that's why Z10 into I1 minus I3, and minus, okay, Z2 into I1 minus I2. So I1 minus I2, which is equal to 0. Then by simplifying this equation, then you will get the equation is like this. Then similarly apply the KVL to the loop 2. Here it is the loop 2. So for this loop 2, here let us start with again with the Z here. Okay. So minus Z2 into I2 minus I1, because the current flowing through here it is. So here it is. Yeah, here I2 minus I1. Then after that plus 4 into I2 and minus here Z2 into again I2 minus I3, because here the current flowing through here it is I2 minus I3, and plus 20 at an angle of 90 degrees is equal to 0. Then by simplifying this, then you will get this equation. Then same way apply mesh I3, because here I3, where is I3 mesh I3? Mesh I3 having already one current source. So that's why then I3 is equal to 5 at an angle of 0 degrees. Then by solving these three equations, then you will get, of course here also you can apply the same Cramer's rule. And by applying the Cramer's rule, so here you will get the finally the values of I1, I2 and I3. So here the value of I1 is equal to 3.15 at an angle of 55 degrees, and I2 here it is what is that, 6.12 at an angle of 144.78 degrees, right? So here I2 is nothing but here it is I2, here it is I2, but here we need to find the value of Ix. Ix is opposite to the I2, so that's why here Ix is equal to minus I2. So already I2 value that you are getting here, it is this one. So minus I2, which is equal to 6.11 at an angle of 144.78 degrees. So this is how we can apply the mesh analysis. analysis. So in this mesh analysis, almost we have covered each and every case, like 2 loops, 3 loops, and 3 loops with current source. And suppose if you are having more than 3 loops, then is there any possibility to convert into the 2 loops by applying the source transformation? That case also we have considered. And another case like the supermesh analysis. Okay, so the supermesh analysis also with respect to the 2 loops and with respect to the 3 loops. And another case, of course, if there is a resistance in series with the current source in between the 2 loops, then in that case also the same way to apply the supermesh analysis or not. So that case also we have considered. And also the AC circuit, okay, and how to apply the mesh analysis for the AC circuit also we have considered. So this video or this class, okay, will give you now if you carefully understood the concepts from this class, then you will able to apply the mesh analysis for any circuit, any kind of circuit, right? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.